Hi, this is Brian Fogarty, and this is a video for Chapter 10 of the book Quantitative Social Science Data with R, second edition. So in this video, what we're going to do is look at measures of association in R. So measures of association gives us literally well, one of those things where it explains itself, right? It's a measure of the strength of the relationship between two variables. And depending, it can also give us it can give us the direction. So it can give us the strength and the direction of a relationship. We look at this after chi-square analysis, which again, chi-square analysis is, in the bivariate case here, telling us whether or not there's a statistically significant relationship between two variables. The reason why we're looking at it after is that if our chi-square analysis shows that there's not a statistically significant relationship, then we shouldn't be talking about the strength of that same relationship, right? It's like saying, this doesn't matter at all, but let me tell you everything about it. It's like that annoying person. You're like, oh my God, I get it. So we only should be talking about measures of association and calculating them if we find that the relationship is statistically significant. There are tons and tons of measures of association, all with usually with someone's name, and then potentially a Greek letter, or spelled out in English, that letter, and then sometimes subsetted in some way. We're going to look at two here. First, we're going to look at a measure of association for when we have one or two nominal variables. And the reason why we're looking at this separate is that if we have a nominal variable, we can't talk about direction. We can't talk about a positive effect or a negative effect because a nominal variable implies there's no order. So we need to have slightly different measures of association for that versus when we have two ordinal level variables where we could talk about a positive and negative effect. So we are going to look at something called CramerV. And this is bounded between 0 and 1. Again, because it's not giving us, so it's not saying like it's always a positive relationship. Again, there's no order here. Where 0 means there's no association, and 1 means perfect. I include some kind of like rules of thumbs about how to interpret the relationship. It's a rule of thumb. It's not necessarily a hard, a law or anything like that. All right, so let's get started here. We're going to use a package called DescTools, all right, but DESC tools. Okay, there we go. It yells at us because we're using the older version. And we're going to do Cramer, see it shows up here, CramerV, and then we are going to specify, you can see how it shows up here. It says X and then Y. So we are going to follow from our previous video on chi-square. We had vote dumb was our predictor, and VF England, VF problem 1. Okay, so we're going to assess the strength here. All right, so this shows a Cramer's V value of 0.12 rounded. So this is we can interpret this as a weak relationship, or a weak association. So there is a statistically significant relationship between people's vote in 2017 and their views on whether or not voter fraud is a problem, but that relationship can be considered weak. Okay. Now, if we have two ordinal variables, we have other measures of association. And some of these have rules that say like you can only use them if the two variables have an equal number of categories, and then there's a different version for whether or not if they have an unequal. The truth of the matter is you're going to probably wind up in the same conclusions anyway. So let's just look at one of these. We're going to look at GoodmanKruskalGamma, which every time I hear, I think it's like it's some sort of like foot cream or something, like fungus cream. And so we can't use the vote from the previous one because that's nominal. We are going to use people's education. So we're looking to see whether or not there's a association between people's education level and their view on whether voter fraud's a problem. Okay, so it's negative 0.11. All right, so we can conclude from that there's a negative weak relationship. Now, what we should really do, given the preamble to this video, is we should look at whether or not chi-square is significant, right? Like, are we looking, like, what are we doing? What is the deal? Hold on. So let's actually, oops, I put this in the wrong spot. I'm going to put this here. But let's take a look at education just to see whether or not, I don't think there's missing. But let's double check real quick. So count education. All right, so there's no missing. So we don't need a filter line. We have VF problem 1, and we're going to include education. Let's do this. Let's actually take a look at the simple crosstab. I didn't include any adorn stuff. We should adorn it. Let's adorn it. I'm going to steal all this up here. This is from the first video looking at crosstabs. Okay, I'm just going to come here, straighten these out a little. All right, let's take a look. Someone's angry at me. Why are you angry at me? Let me figure this out. All right, so yeah, Captain Obvious. We don't have piping there. There we go. That should work, actually. All right, so do we see anything? Maybe I might be stretching it a little. It seems like for this strongly, so the agree strongly agree, as education increases, that goes down. And then vice versa, that for strongly disagree, as education increases, those go up. So there might be. This might explain why it's weak. Right? Because you're like, okay, let's do chi-square test. It is angry with us, let us figure it out. Yeah, so doing a lot of sort of obvious mistakes here. We just need that. Hopefully that works. Okay, so just, I was looking at this because let me just backtrack a little. So this is invalid type character. So I was just double checking, making sure that education wasn't shown up as a character variable. It's numeric, and then that's when I looked up. I'm like, oh, we have the adorn in there, so that's why it's not working. Okay, so the p-value here, again, we're looking for if it's smaller than 0.05, and it is, that this e minus 7 means move the decimal place to the left 7 places. So there is a significant relationship. But that relationship is a negative and weak. Okay, so that is it for this video, just a little bit on measures of association. Thanks for watching. I'll see you next time.